Fundamentals of 3D printing. 3D printing, also known as additive manufacturing, is a process of creating three-dimensional objects from a digital model. Unlike traditional manufacturing methods, such as milling and turning, which remove material from a solid block to create a desired shape, 3D printing works by adding material layer by layer to create the object. The 3D printing process typically involves the following steps. Creating a 3D model. The first step is to create a 3D model of the object to be printed. This can be done using a variety of computer-aided design CAD software. Slicing the model. Once the 3D model is complete, it needs to be sliced into thin layers. This is done using a slicing software program. The slicing software will generate a set of G-code instructions, which tell the 3D printer how to print the object layer by layer. Printing the object, the G-code instructions are then sent to the 3D printer, which begins printing the object. The printer will deposit the material one layer at a time, following the instructions in the G-code. Post-processing. Once the object is printed, it may need to be post-processed to remove any support structures or to improve the surface finish. There are many different types of 3D printing technologies, each with its own advantages and disadvantages. Some of the most common 3D printing technologies include fused deposition modeling (FDM). FDM is the most common type of 3D printing technology. It works by extruding a melted thermoplastic filament through a heated nozzle. The filament is deposited on the build platform layer by layer to create the object. Stereolithography (SLA). SLA uses a laser to cure a liquid resin layer by layer to create the object. SLA printers are known for their high resolution and accuracy. Selective laser sintering (SLS). SLS uses a laser to sinter powder particles together layer by layer to create the object. SLS printers are capable of printing a wide range of materials, including plastics, metals, and ceramics. 3D printing has a wide range of applications, including prototyping. 3D printing is ideal for prototyping new products and designs. It allows designers to quickly and easily create physical prototypes to test and refine their ideas. Manufacturing. 3D printing is also being used to manufacture a wide range of products, from toys and jewelry to medical implants and aerospace component education. 3D printing is a valuable tool for education. It can be used to teach students about engineering, design, and manufacturing. Here are some of the key benefits of 3D printing. Geometric freedom. 3D printing allows users to create objects with complex geometries that would be difficult or impossible to produce using traditional manufacturing methods. Reduced waste. 3D printing produces very little waste, as only the material that is needed to create the object is used. Rapid prototyping. 3D printing can be used to quickly and easily create prototypes of new products and designs. Mass customization. 3D printing can be used to produce customized products at scale. Overall, 3D printing is a versatile and powerful manufacturing technology with a wide range of applications. It is still under development, but it is rapidly evolving and becoming more accessible and affordable. Source: usefuljiprojects.com. How to start 3D PR. The following table provides a summary of the key specifications for some of the most common 3D printing materials. Material: melting temperature C, heat deflection temperature C, tensile strength MPa, impact strength kJm, flexural strength MPa, hardness Shor D. PLA: 180 220, 60 70, 50 70, 24, 50 90, 70 80. ABS: 210 250, 90 110, 30 50, 25, 40 70, 75 85. PEEK: 220 250, 70 80, 40 60, 25, 50 80, 70 80. Nylon: 220 260, 150 170, 50 80, 38, 70 100, 75 85. TPU: 190 230, 110 130, 30 50, 10 20, 50 80, 60 70. PVA: 170 190, 50 60, 20 40, 12, 30 50, 70 80. HIPS: 200 230, 70 80, 30 40, 25, 50 70, 75 80. Carbon fiber: 180 220, 200 220, 400 600, 20 30, 300 400, 85 95. Fiberglass: 180 220, 200 220, 300 500, 15 25, 200 300, 80 90. Kevlar: 190 230, 220 240, 500 700, 25 35, 400 500, 85 95. it is important to note that these are just general specifications. The actual properties of a 3D printed object will depend on a number of factors, including the type of 3D printer used, the print settings, and the post-processing steps performed. When choosing a material for 3D printing, it is important to consider the following factors: the intended use of the object, what are the object's mechanical and aesthetic requirements? The 3D printer, what types of materials are compatible with the 3D printer? The print settings, what print settings are required to achieve the desired results? The post-processing, what post-processing steps are required to achieve the desired results? With a good understanding of the different 3D printing materials available and their properties, you can choose the right material for your project. The primary aspects of a concrete home 3D printer are: print head. The print head is responsible for extruding the concrete material layer by layer. It is typically equipped with a nozzle that can be heated to control the flow and viscosity of the concrete. Robotic arm. The robotic arm moves the print head around the construction site, following a predetermined path to create the desired structure. Material delivery system. The material delivery system pumps the concrete mixture from a mixing tank to the print head. This system must be able to maintain a consistent flow of material at a controlled rate. Control system. The control system coordinates the movement of the robotic arm and the extrusion of the concrete material. It also monitors the printing process to ensure that the structure is being built correctly. In addition to these primary aspects, concrete home 3D printers may also include other features such as sensors. Sensors can be used to monitor the printing process and ensure that the structure is being built correctly. For example, sensors can be used to measure the temperature and viscosity of the concrete, as well as the position of the print head. Software. Software is used to create the digital model of the structure that will be printed. This model is then used to generate the printing path for the robotic arm. Safety features. Concrete home 3D printers must be equipped with safety features to protect the operators and bystanders from injury. For example, the printer should have an emergency stop button and guards to prevent access to moving parts. Current state-of-the-art concrete home 3D printers are still under development, but they have made significant progress in recent years. Commercial 3D printers are now available that can print entire houses in a matter of days. However, these printers are still relatively expensive and complex to operate. Future outlook. The future of concrete home 3D printing is very promising. As the technology continues to develop, 3D printers are expected to become more affordable and easier to use. This could lead to a widespread adoption of 3D printing in the construction industry, which could revolutionize the way we build homes. Here are some of the potential benefits of concrete home 3D printing. Reduced construction costs. 3D printing can reduce construction costs by eliminating the need for manual labor and traditional construction materials. Increased construction speed. 3D printers can build entire houses in a matter of days, which is significantly faster than traditional construction methods. Improved design flexibility. 3D printers can be used to create custom homes with complex shapes and designs. Reduced waste. 3D printing can reduce waste by only using the amount of material needed to build the structure. Overall, concrete home 3D printing is a promising technology with the potential to revolutionize the construction industry. The estimated cost of a concrete 3D home printer in 2023 ranges from $180,000 to over $1 million. The price depends on a number of factors, including the size and build volume of the printer, the type of robotic arm used, and the features included. For example, a small, gantry-style 3D printer with a build volume of 20 by 20 by 10 meters might cost around $200,000. A larger, robotic arm-based 3D printer with a build volume of 50 by 50 by 10 meters could cost upwards of $1 million. In addition to the cost of the printer itself, there are also other costs associated with 3D printing a home, such as the cost of the concrete mixture, the cost of labor to operate the printer, and the cost of permits and other approvals. Despite the high upfront cost, 3D printing has the potential to reduce the overall cost of construction by eliminating the need for manual labor and traditional construction materials. Additionally, 3D printing can be used to build homes in a matter of days, which can save time and money. As the technology continues to develop and become more affordable, 3D printing is expected to become more widely adopted in the construction industry. The future prospects of 3D home printing are very promising. As the technology continues to develop, 3D printers are expected to become more affordable, easier to use, and more capable. This could lead to a widespread adoption of 3D printing in the construction industry, which could revolutionize the way we build homes. Here are some of the specific trends that are expected to drive the growth of 3D home printing in the coming years. Reduced costs. The cost of 3D printers is expected to decrease significantly as the technology becomes more mature and economies of scale are achieved. This will make 3D printing more accessible to a wider range of builders and homeowners. Increased speed and efficiency. 3D printers are becoming increasingly faster and more efficient. This means that homes can be built in a matter of days or even hours, rather than weeks or months. Improved design flexibility. 3D printing offers a high degree of design flexibility, allowing builders to create custom homes with complex shapes and features. This could lead to a more diverse and innovative range of housing options. Reduced environmental impact. 3D printing can help reduce the environmental impact of the construction industry by using less material and generating less waste. In addition to these trends, there are a number of other factors that are expected to contribute to the growth of 3D home printing, such as the increasing demand for affordable housing and the growing awareness of the environmental impact of the construction industry.
Here are some specific examples of how 3D home printing could be used in the future. To build homes in remote or disaster-stricken areas where traditional construction methods are difficult or impossible. To build custom homes that meet the specific needs of individuals and families. To build affordable housing for low-income families. To build sustainable homes that use less energy and produce less waste. To build homes that are resistant to natural disasters such as earthquakes and hurricanes. 3D home printing is still a relatively new technology, but it is rapidly developing and has the potential to change the way we build homes for the better.